Okay, let's finish the annuity section. Find the amount you must deposit in order to hit your financial goal in the given time. So this is opposite. So here you have a certain amount you want, and you have a certain amount of time you have to get there. And now you're trying to figure out what you're going to have to deposit and how often you're going to have to deposit it in order to get there. So find how much you must deposit quarterly in order to hit your financial goal after the given time. You want to have $250,000 after 19 years, and you get a 6% compounded quarterly rate. So how much do you have to deposit every 3 months in order to get there? So if we use that other version of the formula, which is that payment is equal to basically anything from the numerator above goes to the denominator. So payment is equal to A times R over N divided by 1 plus R over N to the NT minus 1. So basically this part from up here and this one flipped. Again, our A is 250,000. R is 0.06, N is 4, T is 19. So you've got 250,000 times 0.06 over 4 divided by 1 plus 0.06 over 4 to the 4 times 19 minus 1. And again, just like this one, where you put the parentheses is important. So we've got 250,000 times 0.06 over 4 divided by parentheses 1 plus 0.06 over 4, close parentheses, caret, parentheses 4 times 19, close parentheses, get out of your exponent, minus 1, close the last parentheses. So we put that into the calculator. And when we do, we get, you must deposit $1,785.37 every month or every 3 months in order to get there. Okay, so if we wanted to see how much money we're actually depositing and how much we get as interest of our $250,000, if I pay $1,785.37 4 times a year for 19 years, how much should I pay? That's the question. Let's see. What is it? 1785.37 times 4 times 19. So you had to pay in $135,688.12 over the years to get to your $250,000 goal, which all things considered isn't that bad. But again, it took 19 years to get there. And saving this much money every 3 months is actually harder than it sounds. $600 a month, while doable, depending on your circumstances, is not doable. Okay, just a few more. I'm gonna leave number 4 for you guys to practice. This is your A. Your rate, 6.9% compounded semi-annually. So this is R is 0.069, N is 2, T is 15. So just keep that in mind when you're doing it. And I just want to do the last problem. Suppose you want to have $1 million. Who doesn't want to be a millionaire? But you can only save $1,000 per year. Someone offers you an amazing 10% annual interest rate. How much will you have to make? How many years will you have to make payments of $1,000 at that rate in order for you to become a millionaire? Okay, so here our N is 1. Our rate is 0.1. Our payment is 1,000. Our goal is $1 million. And really the thing we don't know is actually T in this case. So I've got 1 million, my goal, equals, 1,000 times 1 plus 0.1 over 1 to the 1 times t, n times t, minus 1, all over 0.1 over 1. So I got to solve for t, so I need to kind of unwrap what's happening here. This is 1,000 equals, I'm going to talk about this in a second, 1,000 times 1.1 to the t minus 1, all over 0.1. Okay, to get the 0.1 to the other side, I have to multiply by 0.1. So that gives me to 100,000, because that's the same as dividing by 10. So 1,000 times 1.1 to the t minus 1. Again, I'm going to have to get rid of the 1,000 by dividing by it. 100,000 divided by 1,000 is 100 equals 1.1 to the t minus 1. Add 1. 1.1 to the t then equals 101. And this is where we can use our skills from the last chapter with logarithms. I'm going to take the ln of both sides. So t times the ln of 1.1 equals the ln of 101. So t is the ln of 101 over the ln of 1.1. Remember that by taking the ln or log of both sides, it allows you to bring the t out front. So let's see what this is. Looks like it's 48.42 years. So we probably have to round that up, so 49 years. Now, if we wanted to make sure that this actually works, let's see how much money we would have if we deposited for 49 years, just by plugging in 49 as t in the formula. We have 1,000 times 1.1 to the 49th minus 1, and then divided by 0.1. According to that, if we do it for 49 years, we will have $1,057,189. And that deals with the decimal, all that extra interest we would have accumulated for the rest of time. And that's because the longer amount of time you borrow money, the more dramatic an effect it has. So doing something for 49 years is impressive. But only $1,000 a year for 49 years can get you there. It's impressive. But again, a millionaire now versus a millionaire in 50 years, given inflation rates, may mean different things. You know, the statement that people are like, oh, $1 million doesn't buy you what it used to. Well, in 50 years, $1 million may actually not buy what it used to. So we'll have to wait and see. But that's all for 5.3.